Well, hello folks and welcome to my video. Today I want to talk about data analysis, data analytics workspace, that's career, data analytics overall, or data science sometimes they call it. And along with that, it's the changes that are coming into this profession, just like in many professions in general, IT technologies, information technology. In fact, in many careers and professions, not only in IT, the impact of AI, artificial intelligence, and the current trends, what's going on, and I want to try basically to stick to information that I would call fact-based instead of speculation, instead of misinformation, because as you know, YouTube is particularly is again as usual full of kind of what is it called? Very superficial, very speculative, almost to the point of kind of wild sci-fi kind of movies. AI is coming, it's gonna basically kill all humanity and enslave us. Robots are coming, stuff like that. So hopefully this will be completely and totally refrained from, divorced from those kinds of wild, dumb speculations, and stick to as much as I can to the fact-based information. So yeah, again, the core of this presentation. Basically, I prepared for this presentation actually 23 slide long PowerPoint presentation, so I can kind of collect my thoughts, organize my thoughts into what's going on in the world of AI and its impact, particularly from the data analytics, data scientist perspective. As you all know, that is one aspect of overall information technology profession. So yeah, since we kind of hopefully started to kind of outline in the context, and let's delve into it, without further ado. So I'm gonna look at just kind of read from my slides, and I will put my insights and comments as I go through. So bear with me, please. AI Age Career Roadmap for a Senior Data Analyst, I call this, and I put the years as 2025 to 2035, so which is the next 10 years. Opportunities, skills, projects, and positioning for especially this is, I kind of, in my mind, what I had was, I geared this towards a person, an individual who is just kind of new, starting in this profession, or maybe has been in the profession for the past several years, not really a veteran, but kind of a newcomer, and what this person should be looking forward to for the next 10 years and beyond. So where the best opportunities will be. I have three main points for the main opportunities in the data analytics world. Those are I call high leverage roles. Part one, high leverage roles. Excuse me. Number one, analytics engineer. It is AI augmented. And again, before I continue, I want to specify here one thing. The keyword always, when I think of AI and the current trends, what's happening in AI and its implementation into the technology work especially, the one key definition, one key component or keyword is augmentation. Instead of destroying the jobs, it's augmentation. That means making a lot of jobs a lot more productive. And that is the essential point of my video. Owning the models, owning the semantic layer, the speed, ELT docs and tests with LLMs. LLM is standing for large language models. Yeah, I want to particularly again explain what I mean by semantic layer. Those of you, if you're not familiar, the business end user needs to communicate with the data models and databases and data models in a natural business language. For instance, to give an example, a business person, let's say an executive, a financial decision making, marketing executive, manager, higher level manager, directors, those folks, they're not supposed to. They don't have to know all the intricate details of the how to write a SQL code and to get some information from database. What they do is basically they just write just like a regular plain English with business terms, business concepts, and that gets translated into SQL. That gets translated and communicated to the database systems. That's the semantic layer. That is basically taking care of this kind of, so to speak, translation between business language and natural business language and a technical language that databases can understand and operate. That's what it's called, semantic layer. So analytics engineer should be very familiar with that and actually work with that and develop that. The number two is the decision / insights science lead. So basically, this person designs experiments, performs casual analyses, executive ready narratives that has to be created with AI explainers. Again, it is another kind of a new concept here. Artificial intelligence explainers is kind of like AI agents that work and operate within this kind of environment. And then number three is a data product owner / analytics PM, like analytics project manager. That person defines the data products, KPIs, key performance indicators, data governance, and integrates co-pilots into analyst workflows. Today, co-pilots are coming more and more kind of useful. Microsoft is working hard on them to kind of get the co-pilots integrated into many platforms and environments. Whether it's you're using Microsoft Excel, you're writing a database, you're working with Microsoft Azure for cloud applications. Co-pilots are everywhere and being still, very fast developments taking place. So they're coming very handy, and this person has to be comfortable with working with those co-pilots. Moving to the next slide. High leverage roles continuing, and I call this part number 2. Again, there are 3 main bullets that I have. 1, LLM, again, large language models, / RAG analytics specialist. RAG is standing for red, amber, and green. For those of you who are familiar with that, I know you don't need to have an explanation, but I'm just kind of hopefully making this a little more widespread and kind of wider spectrum of audience, I expect, or I assume. RAG, red, amber, and green are like traffic lights. You kind of present to executive the status. That is where we're at for whatever the projects we're working on, and there are lots of subcomponents of the project that we're working on, right? And we assign on a continuous basis, could be daily, weekly, however it is being structured, the project progression. We assign colors to indicate the status, like say, okay, it is red, careful, there is something going on, we got to explain why we're behind the schedule. Or it's green, okay, we're good with that. Now keep working, keep up the good job, good work. And number 2 is AI, data governance and quality lead. So data governance is not a new concept. Data governance has been around the block a long time. Basically, data analytics space, data governance is one of the essential functions that governs, as the name you can guess, that governs all the data structures. That means the way data is created, stored, when necessary, destroyed, utilized. When data is at rest, that means it is not being used, it's just sitting on a database, or it is being in use through a lot of front-end applications by the end users. That means called in transition, in motion. So all these, and the way they work, the way they are stored, the way the people, what level of access to data, depending on as needed to no basis. So all these are determined by data governance. So that's not a new thing. But AI data governance is making it, again, part of this current trend. So AI is also coming coming into play in data governance and quality lead, I said. That includes modeling the risk, data quality, working with data quality, tracking the quality metrics, data lineage, PII protection, and evaluation frameworks. So all this data lineage, data quality, modeling risks, and all these are coming also under the one data governance group. And the number three is a migration and modernization principle. Applications are lead lakehouse, fabric migrations with AI-assisted mapping and validation. For instance, you're talking about moving data sets, data tables, large, huge. We're talking about thousands of terabytes of data. And let's say you're moving a data center, physical data center, from one physical location to another physical location. So there is a physical, like servers or server clusters, the networks, the way all these servers are being networked. So this is all being moved from location A to location B, when there is also like a cloud-based movement. Maybe you want to migrate from on-premises, in short it's called on-prem, which is on-site physical location that the company, let's say, stores all the data. Now the current trend is moving everything to cloud, right? So these terms like lead lakehouse, fabric migrations are coming into play in this kind of environment. So migration is subject to all kinds of subroutines and works and tests and over tests and endless tests and everything to make sure that data migration is done completely and successfully without messing up anything. So this is the migration and modernization principle. So moving to the next slide. Now we just, so far in those initial 3-4 slides, discussed kind of general, the high level, to try to kind of put things in a context. The data analytics work and working data analysis or data analysts working with AI. And now the second group I'm going to talk about is skill stack to build. So what kind of when you talk about the data analyst or data scientist within the AI age, what kind of skill stack that this person should have? I named this one as core. Keep razor sharp. Core. There are 4 bullets that I'll put here. The first one is SQL or SQL, structured query language, which is the language that anyone can interact with tables on database, regardless of the database. Does not matter whether it's an Oracle database, whether it's a SQL Server, or Microsoft Access, kind of small desktop type of database. It could be IBM DB2 database. Doesn't matter. All these databases, when you're dealing with them, you gotta write SQL code, right? So advanced SQL. And window functions, the CTEs and optimization, cost-aware patterns. So all these are going to be coming into a play when you're interacting with the databases. The cost-aware patterns are one example I can give you is the more efficient SQL queries that are basically taking less resources, utilizing less resources. When you run them, the more efficient SQL statement runs faster, uses less of resources, and it kind of frees up a lot of space for database to run its other functions, so it doesn't create a lot of conflict. And optimization is coming into into play also within the same context of cost-aware patterns and optimization. Window functions, obviously, a lot of times these databases are operating within a platform, mostly in a Windows environment, especially those, for instance, Microsoft Azure, the cloud-based systems. And you're talking about Microsoft, you're talking about Windows environment. The second one I call the Python for analytics. Python is really, when you look at it, number one, the most in demand or popular tool. And not everybody has to be a Python programmer or developer, but it's important to be able to understand how to work and operate within the Python environment, understanding the certain Python concepts, for instance, polars, pandas, DuckDB, or PYL. For instance, what is pandas? When somebody asked me actually the other day, he was telling me that he asked something to ChatGPT, and ChatGPT generated the code in Python, and there was lots of pandas. Saying, "What is it? What the hell is pandas? What is panda?" Uh, for instance, pandas are just variables that are variable generation in Python, and that works with the code. Working with whatever you're working with. Experimentation and casual methods. A A/B design, power, diff and diff, and uplift. Those are all the concepts that are going on in this environment. And then lastly, BI, business intelligence. And look at this again. We're always thinking that is the part I like about this, because business intelligence, when you talk of Power BI, we're also talking about DAX language, DAX language, which is still part of the Microsoft Excel kind of environment. Uh, DAX is a language that is utilized. You can also use it in Microsoft Excel if you're working with Power. I don't want to say PowerPoint. Power Pivot. That's how I was thinking, not PowerPoint. If you're regular pivot tables in Excel. Anyone working at a certain level with Microsoft Excel know how to work with pivot tables, right? And there's also power pivot tables, which are a lot more powerful, as the name suggests, than the regular, single pivot table. And also with the power pivots, the DAX language was incorporated by Microsoft into Excel. This is a different language, the pattern. This is not VBA. This is not Visual Basic for Applications. And DAX works primarily in addition to Excel, also work separately on Power BI. Power BI is also Microsoft product. A lot of similarities it shares in its functions, in its scripting language, like DAX, DAX. Actually, DAX standing for Data Analytics Extension. That's what it's standing for. And it's making Excel a lot more powerful when it comes to data analysis and its integration with all the other systems, the databases and other systems, in this case, Power BI, for instance. Power BI is a wonderful visualization tool and has a powerful means to interact with data analyses. And this is still coming very handy and powerful within the AI framework. So moving to the next slide here, AI First Analytics. That's the title of this slide. And I have, again, four bullets under that. Excuse me. Number one is prompting and tool use. So anyone who needs to incorporate AI into their work in this space, in this case, data analytics space, or developers or other guys, same, they're going to use the term prompting. Prompting is used a lot. The concept of prompting is used a lot in AI framework, because the better you know how to do prompting, a lot more you can get out of AI. To explain that better, I experienced a couple of friends actually asked me, they said, this chat GPT, I can get much out of it. And I said, what was it you were trying to do? And he said, this is what I was trying to do. Okay, how did you ask? And then it was saying, okay, this is what I did. This is what I said. And, this is the response I got. And, it doesn't help me much. And I said, I can see why. You got to ask your question very carefully, in very good logical detail. Again, it's all plain English. It's all plain language. But you got to really think through and structure your question that is in purely rational and logical manner. And then you can start getting a lot from, for instance, ChatGPT. That's what I was using. And I gave him an example. I said, what was it you were trying to ask? This, right? Okay, let me ask this. Let me ask the same question in the way I described to ChatGPT, and I will send you the results. And I did that, and I got results, and he was totally calm, blown away, like, oh, that's amazing. He said, I wasn't even expecting anything like this. And I said, you're not even scratching the surface. But you got to be asking question in a very careful, structured manner. You cannot be vague. You should be avoiding being vague. So that's where the prompting comes into play. That is the way you're asking questions, the way you're prompting AI. That's and the better you're getting at it, the better results you're getting from, in this case, ChatGPT. And the second one is RAG. Remember I mentioned RAG before, red, amber, and green. Those traffic lights kind of showing the status of the project steps, for instance. That in that, like a chunking, embeddings, hybrid search, re-ranking, metrics, all these are part of it. LLM evaluation and safety. LLM again is standing for the large language models. You got to evaluate its test. You got to test it. So there's got to be hallucination checks, prompt injection defenses, and also guardrails. So the hallucination part is let's focus on a little bit on that one. When you ask your question to an AI agent, you might be working with a lot of agents, and I'm going to use as an example here, which is widely I'm using on a daily basis almost, ChatGPT, because it's a very popular, very powerful, very well-known model, large language model. And you can, when you ask your question, you might get a result that is considered hallucination. They're working on this a lot. I know they will be improving. They will be making it a whole lot better coming years. That I have no doubt about it. But currently, still, hallucination issue is a problem. What is hallucination? For instance, you write you ask a question, you get an answer. It might look very good answer, very detailed answer, but it actually may not be right. So that's the kind of scary part, right? How do you deal with that? A lot of developers, they say they're actually dealing with this problem. Sometimes it's costing them a lot of time, meaning they're asking, for instance, let's say a Java developer, okay? A Java developer is building an application, and in part of his application, he's relying on for certain scripts to ChatGPT to kind of, again, keyword, augment the ChatGPT for his production, right? So ChatGPT generates the code, and he takes the code, puts in its place, and run it. Two things might happen, or three things might happen. One, it runs just fine. Everything is cool and dandy, no problems. Two, it doesn't run, or it runs, generates error. Fine, no problem. If there's an error, it's good, because then there's an error, you got information now. And then you ask again, this time ask ChatGPT like, this is the error generated. Help again, work on it again and give me the right answer. You can do this a few times. I did that 3-4 times. Eventually get it right. How do I know it? Because it was producing the right results. But a third thing is more problematic. It writes a code, and you run it. It might run right, but there might be a logical error that you're not aware at that moment. The hallucination is kind of bringing that kind of a risk. So again, what are we talking about now? This kind of situation can be handled with somebody who has a good domain knowledge and experience. Somebody with domain expertise can work with this kind of problem and deal and interact with this kind of problem. If there is no human with the good domain experience, in the case of hallucination I just mentioned, will be only creating a problem. In this case, AI here would be actually risky even to use it. So that's the one good example of where the human interaction is needed. And the last one is a vector and retrieval. So SQL warehouse interoperability, uh, writing, interacting with the right SQL statements, right SQL scripts, right SQL blocks, interacting with the database tables. That's what it's referred to as vector and retrieval. So what you do is you send a SQL script to the database. You're asking a certain question. You retrieve that data set, and that's what the term vector means in this context. And you have to make sure that the retrieval data set is also work and looking good, looking looking correct. So I'm going to the next slide now. Next slide, the title is Data Engineering You Will Actually Use. So now we're talking about, we're in the realm of the data engineering. All these terms in this workspace, in this career, data analysis, data analyst is a kind of generic term, right? And in this environment, you can hear the terms data engineering, data analytics, data scientists. Their roles are not exactly the same. There's a lot of overlappings, but there's also kind of a clean separations as well. So in this case, this one is data engineering you'll actually use. DBT, in parentheses, or SQL MASH, for transforms, tests, and documentation. For a lot of database work, there's a lot of data transformations done. And then for this, the data quality must be in place. For this, a lot of tests must be in place. And also, data structures must be clearly documented. That means there's a, when you think of a database, there's a physical uh, data model and there's a logical data model. So initially, there's a logical data model that must be built, and based on that, physical database structure is built. And all this data structure must be documented because it is completely based on the business structure and business entity relationships. That is what the data model is representing. All the business entities that are all covered in the data model, whatever the purpose of that database. And then all these tables are related to each other as parent to child relationship. And then the relationship, the logical interactions, the relationships between them must be also documented. That's what it means. And the lake house and the warehouse, data warehouses we're talking about. The Microsoft Fabric, like examples are OneLake, Data Factory, Synapse, or Databricks and Snowflake. All these are various different data warehouse applications that are all heavily used in the industry, in the data analytics space. Especially, like for instance, Databricks and Snowflake, Data Factory. These are, so many of them are utilizing the cloud-based Microsoft Azure type or AWS type applications. They are huge, huge, huge. We're talking about thousands of terabytes. We're even talking about nanobytes. 1,000 terabyte is 1 nanobyte. So we're talking about huge systems. And orchestration and quality. That means airflow, perfect plus great expectations, and MLO and LMO PS basics. ML is here standing for machine language, so ML flow is machine language flow. Cost and latency, monitoring and drifting alerts. So basically, there's a lot of built-in systems that data engineers are responsible with, and they have to monitor continuously, or they have to know how to work with them continuously. They build systems, they 24/7 they monitor these systems, these MLOPs, large language models, and those in terms of cost. Again, and latency. Latency means, let's say, and there is a script running, a SQL script running, or set of scripts are running, and they have to generate results, uh, hopefully in a certain amount of time. In all those, especially for the time-sensitive reporting, uh, the timeliness is extremely important. So the latency is coming into being. So that's what they're supposed to be watching. The next slide, governance in regulated contexts. FinTech Edge. FinTech is standing for finance technology. FinTech Edge. And again, here I got four bullets. Those are data lineage, access controls, retention policies. The second one is model documentation standards. That includes bias, impact, and reviews. Third one is preview by design. That's a consent, data minimization, and redaction. And the fourth one is durable modes, reliability, compliance, and trust. See, all these things that I mentioned are listed. The data lineage, model documentation, design, reliability test, compliance test, all these. These are all responsibility of the data engineer or data analysts or data governance people. Uh, AI works in tandem, or these folks can utilize AI in tandem for their work. But again, the validation, verification, and confirmation, and also repairs, fixes, improvements are falling on people, on human factor. So in this case, again, I'm going to refer back to the same concept that I was talking about, augmentation. AI is tremendously augmenting data analyst performance. There is no doubt about it, tremendously. Yet, it is the human factor who has to set up the platform that can best utilize the power of AI to generate results. Again, here I'm referring back to the same thing. This is There is nothing suggesting here replacing AI, replacing people. It's actually strongly suggesting that AI is being utilized to augment the analyst's performance. So I have all these things now. Just the second portion we finished after the first initial part, which was the high level, what's going on. The second one was the skill level, skill set, skill stack. And now I created that kind of a plan, kind of a generic scenario. I call it 90-day action plan. Well, this is more like, you can make it, 90, 180 day, I don't know, a year, 3 years, whatever. I mean, this is just a kind of a scenario, a sample scenario, okay, just to kind of give you an idea. So in the month one, for instance, foundation and stack pick. So pick a primary stack. For instance, Microsoft Fabric plus Azure OpenAI. That's a stack. That's a combination of systems. Move one existing SQL and Excel pipeline to DBT plus DuckDB locally. So you have stuff in your SQL database, maybe even in Excel, in your data sets, or you have your data sets in Microsoft Access or Oracle, different database or SQL Server. So you got that, and move the existing, that's your existing set, into DuckDB database locally. Build a Power BI model. Add an AI-generated narrative. See, look at that. There is again contribution from AI. You can create or generate your narrative using AI. That's gonna be your narrative. That's gonna outline and kind of establish the context, the framework for what you wanna present using your Power BI. Again, what was Power BI? The visualization application. It's sitting on a database, but how you want to use it? You want to do this? You want to do? Well, you got to define the purpose. Without the purpose, you cannot even utilize it. Define the purpose, and you got to kind of write a narrative for this purpose. You can use AI for this. Month number two, second month, AI in the loop. Project one, from natural language to SQL assistant. You remember I said semantic layer, that business executive or business end user can use it, can basically query something using a natural business language, and it can be translated into database, into SQL, so they can talk to database. So that's one thing. Project one. Project two is RAG over analytics docs, data dictionary, metrics, SOPs with citations. And third, log prompts generated by generated SQL outcomes measure speed and accuracy gains. So that is the AI in the loop. So AI agents, again the term agents, can be utilized, can be set to do all these things automatically, and they generate these. Like for instance, I mentioned log prompts or generated SQL, those things. In month number three, reliability and governance. Add data quality tests. Two, add evaluation harness for LLM features, that is for accuracy, latency, and cost. Remember I said, you check for all these things. You check for hallucinations. You check for the latency. You check for accuracy, because AI is going to produce results, but you got to confirm it's human factor. It's data engineer's responsibility to ensure that they're correct. And write a responsible AI playbook for analytics. So deliverables by day 90. If you take that as a kind of example, 3 month, sample scenario, what are the deliverables? 2 to 3 GitHub repos, DBT project, RAG app, natural language to SQL application. All these can be placed in GitHub. 1 to 2 page governance and evaluation memo. You can use AI for this. And walkthrough notebook showing before and after time savings. I also have 12-month outcomes and portfolio. 12-month outcomes. What good looks like. When you say good, what do you mean? What is good? What defines good? Lead an AI augmented analytics initiative, in parentheses, migration, semantic layer, natural language, NL to SQL. Own a metrics catalog with lineage plus tests. Raise executive trust. Run a repeatable AI evaluation process with a cost dashboard. Become the go-to for AI plus analytics reliability in regulated settings. That's the 12-month outcomes. See that the term here, raise executive trust, that's one of the key things, because that is the outcome of any project. Is at the end of it, once the deliverables are presented, unless there is a trust, especially from the executive leadership, it means nothing. It's not going to go any further, however good you think it is. The term good is only valid once and only once there is an executive leadership trust in it. Portfolio projects, part one. There are 3 bullets for this one. The first one is schema and match, reconcile for migration. LLM proposes mappings. DBT, database technology, applies. And the Great Expectations is an application. Validates, and reconciliation of the report. Eventually, reports are reconciled. Explainable KPI Copilot. KPI, again, key performance indicators. Explainable KPI Copilot. Driver analyses, causal hypotheses, and next best texts when a metric moves. In RAG, again, red, amber, and green, over metric definitions plus code base. Answer, how is net revenue defined? With citations plus DBT/DAX resources. You remember I mentioned DAX before. Again, DAX is a language, data extension, data analysis extension in Excel and Power BI. So when you say net revenue, the executive leadership team will question how do you define, how the system defines net revenue. and they must be all clear, clearly visible and explainable. Part 2, again continuing on the portfolio projects, automated EDA and report generator. One command produces a descriptive either PowerPoint or PDF file with charts and anomalies and takeaways. See, we're talking about the finalization stages. An evaluation harness for NL to SQL, natural language to SQL, that has to be evaluated. And good question set, label SQL metrics, exact rate correctness, human in the loop, UI, user interface. The next group of slides are called positioning and signals. Positioning and messaging. The headline: Senior Analytics Leader, AI Augmented Analytics, RAG for BI, Data Quality and Governance, Payments and Migrations. And value propositions. There are 3 lines for the value proposition. 1, 10 times productivity with DBT or /Fabric plus LLM copilots. Those are NL to SQL, Doc, RAG, and narrative. That's one of the first one. The second one is raise executive trust via tested semantic layers, data lineage, and QA, quality analyses. And finally, reduce migration risk via AI-assisted mapping plus automated reconciliation. So these are under all value proposition. Without the sound and clear value proposition, there is no leadership support. Certifications and signals that help. Microsoft Fabric / Power BI plus Azure AI. DBT developer certification. Optional, those are optionals. Databricks or Snowflake multi-stack support. Publish short tech notes on evaluation, guardrails, migration QA. These certifications can be common, handy, and helpful. Risk management, stay future-proof. Don't compete as a generic prompt user. Compete on reliability plus domain. Make evaluation, governance, and cost discipline your signature. Keep one foot in experimentation. Casual LLMs won't replace good design. See, this is the key word here. The casual LLMs, large language models, if they're utilized casually without considering the steps that we just so far mentioned, they cannot replace a good design by humans. The final slide is next steps. I have 3 bullets in that. 1 is select primary stack and start month 1 conversions. 2, schedule stakeholder demo for natural language to SQL plus RAG prototypes. And 3, draft responsible AI playbook tailored to your organization. This makes the 23rd and last slide and concludes my presentation on the function and role of artificial intelligence in data analytics workspace. And these are the examples and scenarios that I was able to come up with, and so many of them based on my work. And again, AI is we're all new. AI is picking up fast and being developed real fast. So like I said at the beginning of this recording, I try to stay away from any kind of speculative work and kind of fancy populist approaches to AI, and just try to stick to fact-based information in how it is being utilized, as much as I understand and I can see, in the world of particularly data analyst in general, information technology, workspace, and hopefully free from all kinds of speculative, bubble and farce, and hopefully gives you sufficient and rational-based, fact-based information. Thank you very much for watching me so far. I appreciate your time. Have a nice day.